Hello, STEM students, and welcome to Learning Activity Plan number 6, which is entitled Direct Current Circuits. This lecture video will be divided into three parts, and this is part number 1. The objectives of Learning Activity Plan number 6 are the following. Draw circuit diagrams with power sources, cell or battery, switches, lamps, resistors, fixed resistors, specifically ammeters and voltmeters. Evaluate the equivalent resistance, current, and voltage in a given network of resistors connected in series and or parallel, and solve problems involving the calculation of currents and potential differences in circuits consisting of batteries and resistors. The presentation will be divided into the following. We are going to discuss in this part, the first part, resistors in series circuit and resistors in parallel circuit. For parts 2 and 3 naman, we're going to have sample problems wherein the resistors are already connected in combination circuit, just like in our discussion of capacitors. So we first discussed the computations for capacitors which are only connected in series, tapos we proceeded with the capacitors naman connected in parallel, and then we have sample problems naman regarding resistors in combination circuit. Ayan. So let's start for part 1, resistors in series circuit. But first, let's familiarize ourselves with the circuit symbols na baka hindi pa natin na e-encounter, no? So I'm going to pause for a moment so I could share that part. Okay, I'm back, and I know you've already seen this simulation because we've already used this last time. Pero nung ginamit natin siya last time, we used the actual uh, depiction portrayal of the circuit elements. Just like the wire, ganito naman talaga yung itsura niya in real life, almost the same. Tapos we have the battery and we have the light bulb and we have the resistor and the switch. Tapos meron din tayong fuse. Tapos ito, mas malaki battery, light bulb, tsaka iba pang itsura ng resistor. Ayan. Tapos meron ding dollar bill, paperclip, coin eraser, and stuff like that, no? May dog pa, tsakahan. Pero syempre, hindi na yan kasama. Dito lang tayo sa ito mga to. Ayan. We will focus here, okay? Syempre, naman natin i-connect sa circuit ang dog natin, no? So instead of using the actual itsura of the circuit elements, we're going to press this thing here. Ayan. Tada! And you will see that there are now shown as the circuit symbols used in constructing circuit diagrams. Okay? So this one is the wire. Ganyan ang itsura ng wire natin. I'm gonna turn off the electrons. And then the battery, I've already discussed this to you. The longer line is the positive and then the shorter line is the negative, and then we can connect another battery, no? Ayan. And then the light bulb is this one. Tada! If you may remember, although baka hindi nyo na nakalimutan nyo na, no? Ayan. Share ko lang ulit. Ito yung ginagamit sa simulation, yung itsura niya. Yung parang bilog, tapos may ganyan. Tapos sa iba naman, pwedeng ganito ang itsura niyan. Bilog, tapos may ganon. Okay, katulad dun sa dati nating picture. So, iba-iba yung, usually maraming symbol para sa light bulb. Okay, iba-iba siya. So, ito yung isa sa mga pinaka ginagamit, tsaka ito rin. And then, of course, we have the resistor. So, i-connect na lang natin yung ating light bulb sa resistor. Tada! Okay, ayan. Tapos pwedeng lagyan natin ulit ng wire. Okay. I-extend natin ang wire. Isa pang wire. Ayan. para ma-familiarize tayo. Pero most na gagamitin natin dyan ay itong resistor, tsaka battery, tsaka wire lang. Pinapakita ko lang sa lahat para if ever mag-electrical engineering kayo, alam niyo yung itsura nila. No? Naku, hindi na siya na-straight. Bastos. Hoy, mag-straight ka nga. Yung totoo, pinahirapan mo ako, girl. Okay, delete ko lang muna tong ano, no? Kasi ayaw niyang mag-straight. So, ayusin ko na lang ng ganito. Yan, tapos saka ko ikakabit ang switcher. At kailangan pa ng isa pang wire. Ayan. So this is a circuit. And this one is considered to be an open circuit because this switch is open. When the switch is open, the circuit is also, of course, open. Now let's see how this circuit diagram looks like when we transform it into the actual circuit. Tada! O, diba? Ganyan ang itsura niya, no? Ayan, okay? And then, ito yung switch natin, open siya. Pwede natin siyang i-close. Tada! Tapos magkaka-ilaw. Okay, ayan, may rays of sunshine. So now, if you close the switch, the circuit will now be closed as well. Tapos parang ironic lang din kasi kapag close mo yung circuit, mag-on yung light, no? Hindi mag-open yung light there, mag-on yung light, no? Tapos pag inopen mo yung circuit, off yung light. Hindi magko-close yung light, ha? Kasi ganun ang ginagamit natin. Please, close the light. Yung totoo. Pwede mong gamitin yan. Please close the circuit connecting the light, o di ba, para pang matalino siya. Okay, so yun yung itsura niya kapag legit, pag hindi, ganito itsura niya. Okay? Ayan. So let's move on. I'm gonna pause again so that I can go back to the presentation. And we're back. So those are the circuit symbols and the ones that you must familiarize yourselves with are the wires, of course, the battery, and the resistor. Now let's proceed to resistors in series circuit. When two or more resistors are connected end-to-end, they are said to be in series. The same goes with capacitor. Nirephrase niya lang dito. But this also means that when the resistors are just connected with one wire, where the current is just moving in just one wire, that is a series connection. So looking at this illustration, yan sa picture, ito yung negative side ng battery and then the current will be from the negative and then isang wire lang yung dadaan sa pangalawa sa R2 tapos sa R1 tapos sa wire ulit o sa positive. Notice that the current here is in different direction. Galing siyang positive, ito tapos papuntang negative. And that's because this picture is following the conventional current. But I'm showing you the real current or the electron flow. Okay? So ito mga A, B, C na to, hindi yan mga junction ha. Iisang wire lang yung nakakonekta dyan. Notice wala namang ibang wire na nakakabit dito, nakakabit dyan, o kaya dyan. No? Dinidepict lang yung mga points kung saan pwede mong ikabit yung voltmeter. So pag gusto mong makuha yung voltage sa R1, kakabit mo dito yung voltmeter sa A tsaka sa B. Tapos kapag gusto mo naman makuha yung resistance voltage across R2, dito mo naman ilalagay yung voltmeter. Points B and C. Yun lang gustong sabihin yan sa atin, no? And here are some examples of resistors in series circuit. Yan, you may see it like this. So, hindi lang siya katulad dito sa isa na may battery tapos straight nasa taas lang. Pwede rin siyang ganito, tatlo. Ayan. And notice that the battery here looks like this. Hindi siya kamukha ng normal na battery. This means that the power supply used in the circuit is not a dry cell or not a battery, no? So pwede ring makakita ka ng ganyan, tapos may voltage pa rin naman yan. Okay, ito. 12 volts. Pwede mo siyang makita ganyan. It's a different way of showing, depicting power supply. And then, it could be also like this. So, mukha siyang walang battery. Pero again, this tells us that this one has a potential or electric potential, and this one also has an electric potential. And since we have 2 points here, this tells us that there is an electric potential difference on either sides of the resistor. So makakakita ka rin ng ganitong itsura ng circuit, and this is still considered to be a closed circuit. This A and B shows us the lower and higher potentials that provides voltage dito sa ating circuit. So kaya ko yung pinapakita sa inyo kasi last time we were limited with the battery lang na ganito. Ayan. Okay, kasi baka magtaka kayo, may makita kayong ganito tapos hindi nyo na mashook kayo, hindi nyo na masagutan, di ba? Okay. So you're supposed to draw your own resistors in series circuit. Tatlo sila. But we're going to do this in class na lang, no? So that I could see if you truly understand how to construct circuit diagrams when they are connected in series or in parallel later. Ayan, so resistors in circuit, series circuit has the following characteristics. So katulad sa capacitors, 'di ba, may kinaracterize natin yung voltage, yung charge, tsaka yung capacitance. So this time naman, we're going to characterize the voltage, of course, and then wala nang charge, current naman, tsaka resistance. For resistors in series circuit, the current is the same in all resistors because any charge that flows through one resistor flows through the other. Meaning, dito sa series, ang nag-equal ay ang current. So, the total current of a series circuit, IT, that's the total current, ito, is equal to the current in resistor 1, equal din yun sa current sa resistor 2, and so on. May I sub n, no? Meaning hanggang dun sa pinakahuling resistor na nakakonect in series doon sa ating circuit. So kung may apat ka, this expression would look like I total is equal to I1 equal to I2 equal to I3 and equal to I4 and so on. Okay? So let's have this example of combination circuit. And then let's take a look at R6 and R7. R6 and R7 are connected in just one wire. Therefore, they are in series with each other. So sa actual class natin, isi-set yun sa Padlet. Pero dito, papanood nyo naman to after na ng class natin. Let's have this as example, the R6 and the R7. If we want to know the total current through R6 and R7, katulad lang din sa ginawa natin sa capacitors, it would become I67. This tells us this is the current, total current passing through resistors 6 and 7. And it's going to be equal to the current passing through R6, that's I6. And then it's also equal to the current passing through R7, and we call that as I7 kasi yun yung current associated with R7. Okay? So, ganun na siya kadali. No? And then, yung nagtototal naman ay yung voltage. So, equal current, tapos yung nagiging total ay yung voltage. So, for resistors in series circuit, the total voltage, delta V, is equal to V1 plus V2, and so on. is the sum of all the individual voltages across the resistors present in your series circuit. So again, kung may apat ka na resistors, your delta V would be equal to V1 plus V2 plus V3 plus V4. Now let's take a look again with the combination circuit that we have used a while ago. So this time naman, ito namang R2 tsaka R3 yung gamitin natin kasi naka-series din naman sila sa isa't isa. No? Isang wire lang naman tong nagko-connecta sa kanila. Okay? And then let's also create the equation for the voltage naman of R2 and R3. So just like in capacitors, we're going to name them after the numbers of their resistors. So it's going to be V23, meaning this is the total voltage across R2 and R3. And that's going to be equal to the sum of the voltages across R2 and the voltage across R3, which is V3. Okay? Ayan. And then, the equivalent resistance naman would be the sum of the individual resistances. So, the R equivalent here is just like the C equivalent or the equivalent capacitance. So, ang tawag naman natin dito ay equivalent resistance. And the equivalent resistance is always greater than the resistances of the individual resistors. Obvious naman kasi mag-a-add up nga siya, no? So, again, kung apat yung resistor mo, this expression would become R equivalent is equal to R1 plus R2 plus R3 plus R4. At syempre, ito na naman ulit ang ating combination circuit. So, balik na tayo dito sa R6 tsaka sa R7. Ayan, naka-series din naman sila. So, if the capacitors that are connected in series is present or are present in a combination circuit, we're going to call the total resistance of them as R, tapos yung number ng resistors, R67. Because this one will tell us it's the equivalent resistance for R6 and R7. That's going to be equal to R6 plus R7. Okay? So, wala na tayong sample dito kasi mamaya or sa next parts natin, i-apply itong mga equations and characteristics, properties ng resistor and parallel circuit. Okay, ayan. So, let's proceed na with resistors in parallel circuit. For resistors in parallel circuit, ganun lang din ulit. Merong branches and a parallel circuit is also known as a current divided current divider circuit. Its purpose is to divide the current. Paano na-divide yung current? Again, naka-conventional to. So, gagamitin ko pa rin is yung real current. Galing negative, so, maglalakbay yung charges, kikreate ng current, tapos ma-encounter niya tong point B, ito ay junction. So, this time junction na to, hindi katulad nun sa series, no? Dito junction siya kasi some current will go here and some current will proceed here. Ayan. Okay, so dinivide niya yung current. Kasi kung ano man yung current na galing mismo sa battery, ayan, maghahati siya. Yung ibang current pupunta dito. Tapos yung ibang current dito pupunta. Okay, ayan. Now here are the properties, ay examples pala muna, of parallel circuits. Again, I'm going to show you the different way of depicting the battery. Tapos ayan siya, ganyan karami, no, apat. Tapos pwede rin ganito. Ito yung battery mo, may wire, tapos dito pa lang magiging obvious na siya ay parallel. So, paano nangyari parallel yan? So, again, mag-start tayo sa negative. Trace natin yung path ng current. Ito, naka-conventional na naman to kasi galing ng positive yung current niya. Dadaan siya dito. Tapos, ito yung magiging junction. And notice, hindi siya katulad nito kasi dito, halimbawa galing A, tapos pupunta siya dito sa unang junction, iba pupunta dito, dalawa lang yung dinaanan niya. Pero dito, dahil tatlo yung naka-connectang branch, ito, Itong papuntang R2, tapos meron pa papuntang R1, saka meron ding papuntang R3. So, pwede yun. Actually, pwede pa yun 4, 5, 6, isang junction lang siya nakakabit. Okay, maghahati-hati pa rin yung current na dumadaan dyan. And then lastly, pwede rin siyang paganto. So, ito yung landscape, ito yung portrait. So, ganun lang din siya. Pwedeng hindi nakapantay yung junction sa mismong wire, ha? Ganun pa rin yung connection niyan. Okay? Ayan. So, let's proceed with the characteristics of parallel circuits. So, kung sa series ang nag-i-equal ay current, dito katulad lang din sa capacitors, yung voltage yung nag-i-equal. So, the total voltage of resistors connected in parallel circuit would be equal to the voltages across each resistor. Ayan. So, kung may 4 kang resistor, the delta V will be equal to V1, equal to V2, equal to V3, and equal to V4. At syempre, mapi-feature naman ang panibagong circuit natin. So, yung gagamitin natin dito is yung R5 and RA. O, ayan. So, papakita ko rin sa inyo. Hindi lang numbers ang ginagamit para mag-represent ng resistors or ng resistances. So here, the one that is surely connected in parallel ay itong R5 at itong RA. Yan sila. So galing dito sa negative, ayan, naghiwalay dito, tsaka yung iba dito, nagdire-diretso, tapos naghiwalay ulit, pa ganyan. Okay, so ito sure ka na parallel yan sila sa isa't isa. Okay, so again, we're going to write the equation for the voltage for R5 and RA. So again, ininame natin yung total voltage nila based sa subscript nila. So we're going to call it as V, pwedeng A5 or 5A. Gawin na lang natin 5A. B5A will be the symbol for the total voltage when we combine R5 and RA. That's going to be equal to V5 and also equal to VA. Ayan. Okay? Now, let's proceed to current. So, dito naman yung current yung nag-add together. The I total will be equal to the sum of the individual currents passing through the resistors or passing in each resistor. So again, if you have 4 resistors, this would become IT is equal to I1 plus I2 plus I3 plus I4. And again, let's have an example of writing equations using a combination circuit. Again, the ones we're going to use are R5 and RA kasi wala na tayong ibang pwedeng gamitin maliban sa kanila. Sila lang yung sure na parallel dito. Okay? Ayan. So we're going to call the current passing through R5 and RA as R5A. And it's going to be equal to I5, the current passing through R5, plus IA, or the current passing through RA. Ayan. And then, the resistance or the equivalent resistance is expressed in reciprocal, and it's always less than the smallest resistor in the group. So, baliktad siya sa capacitance, no? Sa capacitance, kapag naka-series, doon nagre-reciprocal. Tapos, kapag sa parallel, doon nag-a-add. Dito, baliktad. Yung resistance nila dito, when it's series, that's when you add them simply. And then, when it is parallel, that's when you do the reciprocal thing. Okay? So, katulad ng ginawa natin sa equivalent capacitance, we have to express it in a way that we can solve it better. Ayan. So, our equivalent would be the sum of the reciprocals of individual resistances, and then we raise that to -1. So, again, if you have 4 resistors, this will become our equivalent or equivalent resistance pala is equal to quantity 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4 parentheses, close parentheses raised to -1. So again, gamitin natin uling example C. R5 tsaka C, RA. We have to write the equation for that. So the R equivalent for that would be named R5A. And it would be equal to, parentheses, 1 over R5 plus 1 over RA raised to negative 1. Ayan. And again, sa klase natin, I'm going to force you talaga, encourage you to draw your own circuit diagram with 3 resistors connected in parallel with each other. Ayan. So before I end this part 1, let me just remind you of the purpose of this lesson. Actually, the Ohm's law, the V is equal to IR, or the I is equal to V over R, is applied in electrical safety. So yung extensions natin kasi, it's actually connected in parallel, itong mga to. So bakit natin sinabi na nakaparallel siya? Notice, kung naka-series yan, kailangan dapat, lahat may saksak bago siya gumana. Now, notice na yung mga extension natin, extension cords, extension wires, extension sockets, kahit isa lang yung gamitin mo, gumagana siya. Okay? So, isa yung palatandaan na parallel siya. Remember yung ginawa nyo nung elementary, hopefully nagawa nyo yun, no? Yung may light bulb, tapos pag inalis yung isa, hindi na sisindi yung iba. Christmas light na lang, no? Christmas light, some Christmas lights are connected in series. Kapag napundi yung isa, hindi nagagana yung buong Christmas light, yung ibang mga ilaw. Kasi nawala yung isang connection dahil dun sa bombilya na yon. Tapos meron namang mga Christmas lights na nakaparallel. Wherein, kahit mapundi yung isa, dahil nakaparallel, may nakasanga na circuit, na wire, no, yung current, dadaloy pa rin dun sa isang bombilya kahit sira yung isa pang bombilya. Okay? So, itong, ano natin, anong tawag to? Extension ay nakaparallel yan, no? And consistent yung kanyang current na natatanggap. So, remember, V is equal to, I is equal to V over R pala, no? Ayan. So, bakit sinasabi sa atin na ng mga nanay natin na wag natin lalagyan lahat? Ano ba yung nangyayari? Okay? So, ang voltage na pumapasok sa saksakan na ito, galing sa mismong socket natin, ay consistently 220 volts. Ayan. And this is made of the same material. Okay? Yung nasa loob niyan. So, we could assume that the resistance is also constant. Okay? Kapag wala ka pang sinasaksak. Ngayon, kapag dinagdagan mo, ayan sila, nagsaksak ka dito, nagsaksak ka dyan, nagsaksak ka dyan, tapos nagsaksak ka dyan, ayan. Mababawasan ang resistance. Okay, sorry for the interruption, no. Medyo hindi maganda ang boses ko. Ayan. So, as I was saying, I just did something, no? Okay. As I was saying, this circuit is wired in parallel. So, connected siya in parallel, and then the voltage is constant, and then the resistance is also constant. Now, notice, let's recall that the voltage of the parallel circuit is the same. So, kung ano, yung, yung yung voltage dito 220, dito 220, ayan. Bigyan natin number 1, 2, 3. 4, 5, and then 6. Lahat yan 220 volts. Tapos yung resistance naman nila, since this is parallel, notice na maliit ang resistance nito. Natatandaan nyo ba? In parallel, the equivalent resistance of this whole circuit is even smaller than the smallest uh, resistor. Okay? So, the more na nag-a-add ka ng resistor dito, the more na lumiliit yung resistance. Okay? Ng equivalent resistance niya. At kapag lumiit yung resistance, halimbawa maglalagay ka dito ng sasaksakan ng TV. Syempre, may resistance din yung TV mo, TV. Tapos, let's say dito nagsaksak ka ng laptop. Ayan. Tapos dito nagsaksak ka ng washing machine. Grabe. Grabe ka, no? Tapos dito mo sinaksak yung ref. Kaloka ka. Tapos dito nagsaksak ka ng aircon. Tapos dito nagsaksak ka ng electric fan kasi hindi ka makontento sa aircon, naiinitan ka pa rin. So lahat nilagyan mo ng appliances at syempre may kanya-kanyang resistance yan. So nagkabit ka ng isang resistance, ayan ang lalaki ng mga resistances niyan. Tapos dahil habang nag-a-add ka ng resistance, lumiliit yung resistance, lumalaki ngayon yung current. And remember na yung current natin in a parallel circuit is not equal sa kada socket na ito or sa kada circuit element na ikakabit mo sa circuit mo, kundi nag-a-add up siya. Okay? So, constant yung voltage, bumaba yung resistance, tumaas yung current. So, that will result to overloading. And that will also eventually, if napabayaan mo, ay magre-result sa octopus wiring. Okay? That's why dapat nakikinig tayo sa mga nanay natin pag sinasabi nila na huwag mong lalagyan lahat ng ito ng appliances or wag mong sasaksakan ng mga heavy duty na appliances. I suggest na siguro kung nakasaksak na dito yung TV tsaka laptop, mag-iwan ka ng mga hindi nasasaksakan. Pwede mong saksakan siguro yung dalawa pa dito ng anong tawag dito, mga charger ng cellphone, pero wag yung ganitong mga ka-heavy duty na appliances. Kasi yung mga heavy duty na appliances na yan, matataas ang resistance nila, no? Okay, which contributes to overloading. Pwedeng magkasunog pa sa bahay ninyo, masira yung appliances nyo, sumabog, and stuff like that. Kaya makinig kay nanay, no? And then sa mga bahay naman natin, makakakita tayo ng ganito, ayan, which we call as circuit breakers, which is connected in series with other circuit elements sa bahay ninyo for safety purposes. So for example, itong isang to, nakakonekta siya in series sa lahat ng saksakan at ilaw sa kusina ninyo. Tapos meron ding part na sa master bedroom, meron sa part na sa CR and stuff like that. So may kanya-kanya siyang mga appliances na naka-series siya or may kanya-kanyang mga sockets na naka-series siya. We know naman that in a series circuit, halimbawa ito yung circuit load mo, ito yung power source. Siyempre, hindi battery yung power source sa bahay nyo. Imagine mo na ganyan. Tapos, siyempre, may switch. Ito ay nagsisilbing switch ng isang malaking series circuit na hindi basta-basta resistor lang. So, itong part na to is like one room, everything, every kuryente connected in one room. Ayan, tapos may switch. Okay? So para gumana yon, syempre dapat naka-close yung switch para ma-close yung circuit. So ang gagawin nyo ni circuit breaker, pag nakadetect siya ng overloading, automatic i-open niya yung circuit. Okay? So mamamatay na yung anong tawag dito, yung kuryente, mawawala yung kuryente dito sa part na tong bahay ninyo na nakakonekta dun sa particular na switch sa circuit breaker. No, ayan. So bakit kailangan kabit lang siya sa isang part. Kasi for example, nagka-overload sa isang part ng bahay niyo, hindi na madadama yung other parts. Okay? And the circuit breakers are smart stuff. They detect overloading and they automatically opens the circuit so that no further damage uh, would be done, would happen pala to your house, no? Ayan. Noong unang panahon, wala pang circuit breakers, mga fuse box yung ibinababa, alam niyo yun. Ayan. Pero most of the time, yung mga fuse box, kailangan mo silang laging palitan yung mga fuse. Kasi ang ginagawa naman nun, imbis na para lang siyang switch, ang gagawin niya ay susunugin niya yung sarili niya para maputol yung circuit. So imaginein mo kung fuse to at hindi to switch sa circuit breaker, masusunog yung loob ng fuse na yan. Siyempre, pag nasunog yan, madi-disconnect. Although hindi naman delikado yung kanyang pagkakasunog. So parang magsu-suicide siya para mailigtas yung buong bahay niyo. Pero ngayon, bihira na siguro sa mga probinsya na lang ginagamit yung mga fuse box. Most of the time, ang standard na sa mga household, lalo na dito sa Manila na mataas ang demand for electricity, ay yung mga circuit breakers na. So yun lang for part 1 of our discussion. See you again to See you again in. See you again on. Basta, see you sa part 2. Again, thank you for listening and bye-bye.